Hello, today I'm going to be talking about how to provide clean water in developing countries. So, first off, in countries like Sudan, where poverty and scarcity are strongly present, the most efficient way to provide clean water would be fog harvesting, not solar stills nor desalination. So, I'm basically going to be comparing these three solutions based on their cost, their durability, and their impact on society. Quick background info. In 2015, the 2030 Agenda for Sustainable Development was made and included 17 different goals to go towards sustainable development. One of the goals, more specifically the sixth one, is to ensure availability and sustainable management of water and sanitation for all. So in countries like Sudan, where we're currently facing a water crisis, changes need to be made to fulfill that goal. There's currently a lot of water scarcity problem over there because the water doesn't get managed well. The inhabitants usually have to walk big distances daily to get water from rivers, but even then, the water is often not sanitary. So it leads to a lot of health problems, safety, and education problems. So we'll start with the first solution, fog harvesting. It's basically just a vertical mesh that accumulates droplets of water and then eventually makes them collide and actually forms the water later on. It gets collected into a tank afterwards, as you can see here in the picture. As far as the three criteria goes, for the impact on society, it actually helps promote gender equality because since it's not really that much high tech that goes into this, pretty much anyone can do it. It's a lot of basic knowledge, and they usually end up giving it to women. So once it's back in Guatemala, they gave this task to women, and once it was completed, the village and all the men, they actually had more respect for them, therefore actually promoting gender equality. As far as the durability goes, it really requires low maintenance and resources after being built. There's not really any need for constant supervision once it's done. And for the cost, it doesn't. The cost varies depending on the material and the size, but usually people can use local, low-cost materials to build it, so it can actually come out to being pretty cheap. It's really not that expensive. It's usually in between $25 to $50 per m² of mesh. Second method is solar stills. It's basically a reservoir water that's exposed to the sun. And in reaction to the sun, the water gets evaporated, leaving all the impurities and the salt at the bottom of the tank. And then the water that got evaporated gets condensed and collected into a tank in the end. For the impacts on society, this actually helps with solar energy development, and it leads to more innovations in that field. Like for example, in Sudan, they ended up making solar cookers, solar water heaters, solar dryers, and that actually helps also towards climate change, like going towards a renewable source of energy. As far as the durability goes, it usually doesn't require that much maintenance or supervision once it's built, but there are often potential glass accidents or system failures that can occur, and those usually cause big contamination of water, high reparation costs, or safety problems. But to actually build the solar to begin with, there needs to be a lot of investments because the construction costs are pretty high. There needs to be a lot of money involved. There's also needs to be a lot of science and knowledge around the whole solar energy development to know where the sun is strong, where there's a lot of radiation also. Basically, there's a lot of stuff involved and resources. For the last one, reverse osmosis is basically a type of desalinization. It's essentially a separation between water and its impurities. When you put the salt water in, you apply pressure to it, and that's going to cause a difference of pressure on both sides of the membrane. That difference in pressure is going to make the water go to the other side of the membrane, therefore filtering it. And that's going to be able to stabilize the difference in pressure. That's what actually makes the water go onto the other side. As far as the criteria goes, The impact on society is actually not a good one. The water that gets left out on the other side of the membrane, it gets put back into bodies of water, and it leads to water contamination, and it can be harmful to the whole marine environment because it ruins the quality of the water. For the durability, there's actually a constant need of input. There's a constant need of energy, chemical, and labor that needs to put into it in order for reverse osmosis to happen. So it gets pretty demanding over time, and the membrane could actually degrade due to those chemicals. So you always need to be taking care of that membrane. As far as the cost goes, the chemicals that always need to be constantly put in the membrane that you actually have to buy, those are pretty pricey. So it adds up to being a lot in the end. So basically, in conclusion, the best way would be fog harvesting because it's the cheapest, it's durable, and it has a really good impact on society. So yeah, thank you for listening.